Let us have some examples. So let a coin and a die rather be tossed. If the events, that should be plural, if the events are defined as follows. Event A, a head and an even number appears. Event B, a prime number appears. And event C, a tail and an odd number appears. We're asked to find the outcomes, not the probabilities, but the outcomes of the following events. A or B complement occur. A and B occur but not C. Only C occurs. Pause the video and try to see if you'll be able to give the outcomes for these given compound events. Let's start with number 1 rather. A or B complement occur. So in symbols, this is A union B complement. That would mean we need to look what are the outcomes of A and of B, then B complement. So first, the sample space. A coin and a die be tossed. So that would mean that if you have a coin, the sample space of that is heads, tails. If you have a die, the sample space of that would be 1, 2, 3, 4, 5, 6. So combining them, I better write that one first here instead. Sample space would be head, then 1, head 2, head 3, head 4, head 5, head 6. Then tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So those are the elements of the sample space of our experiment. For A, we only need head and an even number appears. So for head and even number, that's just H2, H4, and H6. For B complement, B, a prime number appears. So B complement, a prime number does not appear. So let's just take all those who are not prime numbers. So that's H1, H4, H6, T1, T4, T6, T6. And if we're going to combine them because this is union, A union B complement will have the following outcomes. H1, H2, H4, H6, T1, T4, T6. And there you go. How about for number 2? A and B occur but not C. So A and B occur but not C. So that could be C complement. There you go. So we already have B. A prime number appears. This is B complement. So we can just get B from there. So prime numbers would be H2, H3, H5, T2, T3, T5. That's B. I did not write A anymore because A is there. C complement would be a tail and an odd number appears. So that means we should just have to make sure that what is here doesn't have a tail and an odd number. So for C, so if there's no tail, that means all heads are okay. 1, 2, 3, 4, 5. Then if a tail does appear, it should not be an odd number. So T2, T4, T6. Now, we have to find what's common with them. So H2, that is something common with them. So that would be A intersection B intersection C complement. So that would be H2. And if you're going to look at it, it's actually just H2 that is common. H4 is common between A and C complement, but not in B. So it's only H2. So the outcome of this event is just H2. Lastly, only C occurs. So for C is a tail and an odd number. So for letter C, that would just be a tail and an odd number, T1, T3, T5. And there you go. Let's have another example. 3 horses, A, B, and C, are in a race. A is twice likely to win as B, and B is twice likely to win as C. It is impossible to have a tie in the race. So let's determine the probability that A wins, C wins, A or B wins. Pause the video and try to answer this problem. Alright, so we have in a race, so that will be our sample space A, B, and C. A is twice likely to win as B, and B is twice likely to win as C. So that would mean if C wins once, B wins twice as likely as C, and A will win twice as likely as B. So we can set it up like this. Anyway, if you're going to have other values, we just have to multiply them as such. So there will be 1, 2, 3, 4, 5, 6, 7 possible outcomes in this race. So the probability that A would win would be, since A can actually win as 4 times compared to C, over 1, 2, 3, 4, 5, 6, 7, the 7 multiples of outcomes, which is just 1 and the same, that means the probability of A winning is 4 out of 7. In decimal form, in 4 decimal places, that's 0.5714 or 57.14%, more than half. The probability that C wins will just be 1 out of 7, or 0.1429 or 14.29%, a smaller chance. If A or B, the probability of A or B, that would be the probability of A already, which is 4 out of 7. Now, the probability of B wins. Since it's impossible to have a tie, A and B are mutually exclusive. So we can just simply add the probability of A to the probability of B, which is actually 2 over 7, which will give us 6 over 7 probability, or in decimal points, 0.8571, or an 85.71% chance that either A or B wins the race. Another example. 6 married couples are standing in a room. If 2 people are chosen randomly, find the probability that the 2 randomly chosen people are married, and one of the chosen is a male, and one of the other chosen is female. Pause the video and try to answer this question. Alright, so our experiment is that if 2 people are chosen randomly out of 6 married couples, that will mean that the cardinality of our sample space will be 6 married couples. That's 12. Since we're randomly choosing 2, that will be the combination of 12 taken 2 at a time, which is equal to 66 ways. For our first event, the 2 randomly chosen people are married. So the probability that we are going to get a married couple, we know that the cardinality of married couples would be 6. That would mean this probability would be 6 over 66. 6 married couples over the 66 pairs, which leaves us to 1 over 11, which is in decimal form 0.0904, or 9.04% chance that when you randomly choose 2 people, they will be a couple. For number 2, one of the chosen is male and the other chosen is female. It doesn't seem that order is important. So that means the number of ways of choosing a male, if we have 6 married couples, we have 6 males, and choosing females is 6. Since order doesn't important, we don't need to swap out the 2. It will just be the same. 6 times 6, 36. That would mean that the probability of choosing 1 male and 1 female in any order will be 36 over 66, or 6 over 11 in lowest terms. In decimal form, 0.5455 or a 54.55% chance, a more than half chance that when you pick randomly two people, they will be one male and one female.